This video is for 15.1 homework, so if you are still needing help with fair share and balance points, then be sure to follow along with this video. So number 1 on our homework tells us that 4 friends, we know we've got 4 people, fished for crabs. They each caught, so not each, they respectively caught 5, 7, whoa. Okay, they caught 5, 9, 8, and 6 crabs, and they agreed to divide them evenly. So how many should each person get? So as we're doing that, I'm just going to think about this number line here. So here's 1, 3, 5, 7, 9. So one person caught 5, one person caught 9, one person caught 8, and one person caught 6. So I should say, right, my balance point should be somewhere here in the middle. So how many crabs should each person get? So I want to find the total crabs they caught and then divide it by 4 total friends. So here is 14 plus 6 is 20 plus 4 is 28. And I'm cutting that into 4 friends. So go ahead and do 28 divided by 4. So that is 7. So they should each get 7. Right? I can see that these are balanced on either side of that. So this is 1 away and 2 away is 3. This is 1 away and 2 away is 3. So they each have a distribution of 3 crabs on each side, and they've got to make it so that they get to 7. So describe how we should distribute the crabs, right? So we've got to get everybody to 7. So that means we've got to give one of these over here. So this person's crab, right? This has to go 1 and this has to go a distance of 1 to get to 7. So this person with 8 is going to give 1 crab to the person with 6. And now they both have 7. Then this person with 9 has to give 2 crabs to the person with 5. Now they both have 7. So, right? We're just balancing everything to get to that 7. This person had 1 more. This person had 1 less. Combined, they both have 7. This person had 2 more. This person had 2 less. Combined, they both get 7. Number 2 says that 5 pages of a photo album contains 6, 7, 9, 10, and 13 pictures. Can the pictures be arranged so that there is an equal number of pictures on each page? Explain why or why not. So let's start and see. So, right, we've got 5 pages, and these are the pictures that we have. So let's see how many total pictures we have. So go ahead and add these up and then come back when you're ready to check. So I can see 6 and 7 makes 13. And 9 and 10 is 19 and another 13. Here's 12 plus 3 is 15 and 4. So we have 45 total pictures. And we want to cut that into 5 pages with the same amount on every page. So go ahead and do that. Now, if this number goes in here perfect, then I would say yes, there's no remainder. We can put exactly the same number of pictures on every page. If there happens to be a remainder, though, that's anything but 0, that's going to tell me that no, we can't put an equal number of pictures on every page, because then there's going to be some pictures left out. And maybe these are all really important pictures to them and they can't choose which ones they would not include. So if it's perfectly even in here, 5 is a factor of 45, then yes, they could make an equal number of pictures. If there's a remainder, then they would have some pictures that they would have to leave out. So that would not work for them. Number 3 says we have 4 stacks of cubes here. So this one has 4. This one has 1, 2, 3, 4, 5, 6. 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7 cubes. So how could the cubes be stacked so that there is the same number of cubes in each stack? So it's not telling us that we have to keep 4 stacks. So that's one important thing to notice, is that we can make as many stacks as we want as long as there's the same number in every stack. So let's start and see how many cubes we have. Oh, these are great compatible numbers. So here's 10 and here's 10. So together we have 20 total cubes. So we just want to think of factors of 20. 1 times what is 20? 2 times what is 20? Can 3 go in there? Can 4? Can 5? Can 6? Can 7? You're just finding factors of 20. So I can see 3. If I have 3 stacks of 6, so here's 6, 6, 6, that's only 18. That is not going to complete this particular problem. So yes, the stacks are equal, but they didn't use all of the blocks. We've got to use all the blocks and keep your stacks equal. So go through and just see which of these multiply, which of these are factors of 20. So 6 and 3 make 18. That's not how many cubes we have. So go through and see which of those make 20. Number 4 says that Tatiana has 3 dogs. She has the following amounts of dog food left. So this much of A, B, and C. The food is going to be distributed evenly to the 3 dogs. How many cups of dog food should each dog get? So we want to combine all of our dog food together. And then we want to split it or distribute it to the 3 dogs. We're going to put our dog food together and then give it to the 3 dogs. Number 5, we've got these 4 stacks of cubes. What ways could the cubes be stacked so there is the same number of cubes in each stack? So this is very similar to that other problem we did. So first we want to know our total. Oh no, my lights are going out. So first we want to find the total number of cubes. Then we're just looking for factors. This number times this equals that. So for example, if there were 8 cubes, so I'm just giving an example. There's not 8 cubes here. There's more than that, right? I could say that I could make one group of 8 or 8 groups of 1. I could make 2 groups of 4 or 4 groups of 2. 3 can't go in there and I already have 4. So I could only make 4 different options using the multiple of 8. I can make one group of 8, 8 groups of 1, 2 groups of 4, 4 groups of 2. So find your total and think of all the ways you could multiply to get to that number, right? 8 times 1 is 8. 2 times 4 is 8. I used all the cubes. So again, this is just an example. You'll want to count the cubes up here to be able to find these answers. Number 6 says that Alex has 36 pennies. He wants to stack them in equal rows. So again, it doesn't tell us how many rows he can have. So we're thinking of factors of 36. So 1 times 36. So ask yourself, can 2 go in there? Can 3? Can 4? Can 5? Can 6? Can 7? Can 8? Once you have a number, so we're back here on this 8 one, right? I did 1 and 8. Then I went 2. 2 times 4 is 8. I said, can 3? No. And I already have 4, so I know that I'm done. So use that same strategy here and find which of these multiply out to make 36. So I can see one here. I'll pick one here. 5 stacks of 7. So that'd be 7, 7, 7, 7, 7. 7 times 5 is 35. So these are not factors. So this one does not use all of his pennies. Hey, what is the balance point for the data set? So we've got 1, 3, 5, 7. So we've got a 1, we've got a 5, we've got a 7, a 3, and a 4. So we know somewhere in the middle here has got to be our balance number. So 1 plus 5 is 6 plus 4 is 10, and 7 plus 3 is 10. So together we have 20. Now we have 1, 2, 3, 4, 5 numbers we're trying to balance. So we want to split our data between all 5 numbers. So 20 divided by 5 tells us that what our balance point is. which is 4 here. So, right, I can see these are both 1 away. So I'd give the 5 to the 3. And then these are 1, 2, 3 away. 1, 2, 3 away. So I'd give 3 of these ones from 7 to the 1. And then they would all have 4 equal pieces. So balance point, fair share, average, mean, those all equal. That's the same word. We're finding the middle. We take the numbers, put them together. What is that number that makes it so all of them would have the same amount? Okay, number 8 wants us to find the volume. So remember, volume is length times width times height of this rectangular prism. So the length is 6.5. The width is 4 3/4, and the height is 3.5. So as we're doing this, we want to make these improper. So multiply, add, multiply, add, multiply, add. See if anything cancels out. And then multiply the numerator, multiply the denominator, and simplify. Number 9 says that Miss Castillo spent $87.75 on shrimp. This is how much the shrimp cost per pound. How many pounds did she buy? So we're going to take our total. We're going to divide by how much each pound was. That will tell us how many pounds she bought. So this we need to move over 1, 2. So that means we're moving this over 1, 2. So we are really doing the problem 975 divided by 87.75. So we had to move the decimal 2 places, move it 2 here to keep it balanced. So I know it can't go in here, and it can't go into 87, and it can't even go into 877. So there should be a number above the 5. And we could have a decimal place. I'm not sure if this goes in here perfect or not. So we might have to bring down that 0 to find a decimal, right? Because maybe she didn't buy exactly 3 pounds. Maybe she bought 3.5 pounds or something like that. So go ahead and divide and see how many pounds of shrimp Mrs. Castillo bought. And last one for today says that Janelle earns $12 every hour. That's right. Every time she works 1 hour, that equals $12. So 1 hour is $12. What equations, so I know equations have equal signs, can be used to find out how many hours Janelle worked if she earns a total of $360. So we have lots of equations we could write here. So I know this is my total of $360, and it's going to equal something with the 12. So right, every time she works 1 hour, that's $12, 2 hours, 24. So I'm going to use H for hours. And so think about what would you do with 12 and the H's to make that equal 360. So if she works 1 hour, that's $12. So that's not enough. 2 hours, 24. 3 hours, 36. 4 hours would be, so we're trying to find out the hours. So what would you do using H and 12 to finish that equation there? And there is more than one way that we could do this. So we could also have H be the answer of hours. So, and put our 360 and 12 over here somehow to get to H. So lots of ways to do the same equation. Just go ahead and finish those up on your homework. If you have any other questions on that, please let me know and we can set up a time to meet together.